The gross domestic product, GDP, is the monetary value of all the goods and services produced within a country in a specific time period. The GDP per capita is the value divided by the population. One model says that the GDP per capita in the United States was $13,513 in 1946, and it has increased by 2% every year. Write an equation to represent the GDP per capita after T years, where A represents the initial GDP in 1946 and R represents the rate of growth each year. If the initial year was 1946, the initial GDP was 13,513. So A is 13,513. The GDP grew 2% each year, so R is 2% or 0.02. So plugging those numbers into our framework here, we have y equals A times the quantity 1 plus R to the T value. So we've got 13,513 for A and 0.02 for R. When we simplify, that gives us y equals 13,513 times 1.02 to the T power. In this equation, y is the GDP per capita and T is the time in years since 1946. If this trend continued, calculate the GDP per capita in 2016. What value will you substitute for T in the equation? Okay, so T is the time since 1946. So we want to know how many years since 1946 is 2016. So that's 70 years. Using this formula that we came up with here, the GDP per capita in 2016 was, so we've got 1.02 1.02 to the 70, and we multiply that by 13,513. So we get 54,046. Why do you not substitute 2016 for T to determine the GDP per capita in 2016? Write down your answer in your notes and have it ready to go for later. And our study tip for this video: the actual rates of change for the GDP are calculated annually and have varied from negative 11% to positive 18%, depending on the current economy. For the purpose of this lesson, we will assume a constant rate of change is present. So in actuality, it's not going to be the same every single year. But for the purpose of this example and practicing working with exponential functions, we're going to pretend that it is the exact same every single year.